Hi, welcome to another edition of Fun with Conceptual Physics, the Momentum Edition. These questions in this reading guide I'm going to go through with you, the ones I've highlighted. So, the equation for momentum, you wrote it up here, or you will, is P, which is a symbol for momentum, equals mass times velocity. Well, we know the units for mass are what? Anyone? Anyone? Anyone out there? Oh, kilograms. And the units for velocity are, you over there in the hoodie, what did you say? A little louder? Oh yes, meters per second. Then when you multiply kilograms times meters per second, the units for momentum are kilogram meters per second. Next, which has more momentum? A submarine moving, a rowboat moving, or the same? Well, if they have the same velocity, then whoever has more mass, and last time I checked, submarines have a lot more mass than rowboats. On this one, who has momentum? A submarine at rest or a moving rowboat? If velocity is zero, think about that. So what determines momentum? First, if you don't have a velocity, you have no momentum. I don't care how large of an object you are. Second, if you have the same velocity, whoever has the most mass. In this one, the rowboat would be moving, even though it's a smaller mass. It has some velocity. Any velocity is better than none. So when velocity is zero, momentum is zero. Please remember that. That'll be a test question. Now, this one's easy. Again, if something's at rest, it has no momentum. That's the idea of this. So if you are at rest, it means your velocity is zero. This is multiplication. 0 times mass gives you 0. You do the last one on your own. Which has more momentum? Oh, wait a minute. They're both at rest. Then they would have the same momentum, which is 0. Hopefully you've kept up. I'm going to move on. Down here, explain how an impact can be reduced by driving through a haystack. In impact, which I give the symbol J, is a force, an impulse is a force times delta t. So in the book they use the word impact. An impulse is a force times a time. If I want force to go down, then what has to happen to time? If force is going to decrease, then time has to increase to balance it. What does a haystack do? It slows you down over a larger time, which means time's going to go up. It takes more time to stop. In class, we'll do some demonstrations like when you do an egg toss. When you toss an egg to somebody, if you catch it quickly, it'll break. But if you cradle it, and I'll demonstrate that in class at some point, if you increase the time, the force goes down and things survive. What is impact? Impact is another word for force. Why do boxers hit a padded punching bag rather than a wall when they're training? Well, they increase impact time, which decreases impact, so they don't break their hand. Again, what they're doing is they're increasing time so that force decreases. Switching over, think of few safety devices in a car can help reduce impact. Explain two of them in the following space. First thing was the greatest revolution. Think of a few safety devices in a car that can help reduce impact. Impact is the force, so put the word force here. We want to decrease force. We want force to go down, which means time has to go up. During a collision, you want to stop over a long time. To do that, seatbelts. Seatbelts increase impact time. Means you don't come to a sudden stop, you take a long time to stop. Next thing are airbags. Airbags are the same thing. They increase time. Moving down here to 21, give an example of a collision not mentioned in your text that would qualify as elastic. I'm not sure what's in the text at this point, but anything that bounces, elastic is bounce. This is stick, inelastic. Well, you can think of a couple. Think of something where two things collide and they bounce and don't stick together. I would say a golf ball and golf club. Here's the golf club and here's the golf ball. Even though the golf ball, and I'll put it on a tee, is at rest, they're going to bounce. The ball bounces off the golf club. Can you think of one on your own? You do that right now. Think of your own and write it down. Example of something that sticks, well, a snowball hitting a moving car. Snowballs stick to cars when you hit them. They don't normally bounce off. So you think of one where something's thrown or two things collide and they stick. I could think of something, maybe you're driving down the road, riding down the road on a motorcycle or driving, and a bug hits your safety glasses and sticks to them. The bug will explode and hit your safety glasses. That sounds nasty, but it is an inelastic collision. You think of something on your own here and on your own here where two things collide. One thing could be moving, one thing could be stationary, but they bounce apart. Here, think of something where when there's a collision, the things are stuck together after the impact. Well, there you have it. That's the extra notes on this. Save this sheet and this sheet. You'll be needing to finish these at some point. Do not lose these because these are your reference on this next test.